Man, that explains us, really explains us. The spokesperson says that statement comes after the government looked at several data sources other than this tape, although they will not tell us what those data sources were. With us now, the physicist, Michio Kaku. He is the author of Physics of the Impossible and is about to explain to us exactly what happened. Thank you for coming.
Glad to be on.
Help me. You've gone point by point by point.
Frame by frame, I've gone through the video tape.
So you stopped this video and you looked at frame by frame by frame, and what did you learn?
At first, I thought, oh my God, an unauthorized launch of a ballistic missile. This is scandalous. This
Or
is
an accident.
Or an accident, right?
Yeah.
But then I said to myself, wait a minute. When you go frame by frame, something is wrong. First of all, the object is not accelerating. Rockets have booster rockets that take it to 18,000 miles per hour. This thing is cruising at a constant velocity. Second, it's changing direction slightly. Ballistic missiles never change directions. Third, it's going in the wrong direction. We fire from Los Angeles, Vandenberg, we fire east to west to Kwajalein in the Pacific, sometimes north over a polar orbit. This thing was going northeast in the wrong direction. And also, even though it looks like it's going vertically up, maybe you're looking at it edge on. When you look at an airplane going edge on, it looks like it's going straight up when it's actually cruising very gently. Not only that, contrails expand rapidly at the base. The older it is, the larger they expand.
Like the contrail right there.
Right. So it looks as if that thing is moving away from you, right? Actually, it's probably moving toward you.
Huh.
It's an optical illusion caused by the fact that we look at the bottom, we think the bottom is closer than the top. When actually,
it's fatter.
Yeah, because it's fatter, because the contrails expand. Now, there are airplanes from Hawaii to Phoenix that go right over Los Angeles at around exactly the time which is in question. So it's probably a commercial airliner that is cruising very slowly, and the killer is, this is now the smoking gun. We have radar analysis of the entire area. We see no evidence of a fast-moving object. All we see are airplanes. That's all we see in the area. So why doesn't the Pentagon simply come out and say what we physicists believe, that it is an airplane? And the reason is it's always hard to disprove a negative.
Right.
It's always easier to prove a positive, but to disprove a negative is very difficult. You can't rule out this possibility or that probability with a certain % error, right? That's why the Pentagon is being very coy about this, I think.
Well, you know, my problem with all this from the very beginning has been we keep track of every single aircraft and every part of our sky at every second of every day. Every 4.3 seconds it updates.
Right.
So we know where every jet is every 4.3 seconds. So can't they look at this video and go, oh, this was United 1231 en route from... I mean, that would help. Why put us through all of this?
Well, it's hard to disprove a negative. In other words, the radar...
But if you were the FAA, you can say, all right, we know exactly the time this was taken because it went live on their air.
Right.
They can say this was this flight. Why won't they?
I think they need a new PR director.
Okay.
I think that's what they really need, because they really need a dose of reality. You know, the Pentagon has to interface with the public.
Yeah.
The public is the taxpayer. They pay the bills. And the taxpayer has a right to know what is going over their skies. And also, jet pilots also weighed in on it. They say they saw nothing unusual. But how can you say that when there was this gigantic contrail in their own backyard?
Yep. Why wasn't everybody on the coast screaming?
The answer is jet pilots look down from above where it looks horizontal and ordinary. We look at it from the bottom up, and we see these gigantic plumes of gas shooting straight up. But somebody up there looking down sees a horizontal plume of exhaust. Therefore, that's why the pilots say, I saw nothing. There's nothing out of the ordinary there.
It's a jet, isn't it?
It's a jet. In other words, you look at all the dots, and you take the simplest line that goes across all the dots, and that's a jet. Sorry for all you conspiracy buffs.
Well, I'm sure they were having fun with it. We were enjoying the video, but I can tell you're very smart. You know exactly what you're talking about. But at the end of this program, I'm going to show them what it really is. It's aliens. But I'm going to show them how it works. Thank you for setting us straight. Very helpful. One charity finding a relatively...
Yellowstone in northwest Wyoming, land of geysers, mountains, and lakes, is also sitting atop a super volcano. And it just took what scientists describe as a deep breath, causing miles of ground to rise dramatically. So what does this mean Well, joining us right now is Michio Kaku. He is a physics professor at the City University of New York and the author of the upcoming book, Physics of the Future. Thanks so much for joining us.
Glad to be on.
So, the last time this happened was 640,000 years ago. We're due?
We are due. Forget Yogi Bear. Okay, forget Old Faithful. It's sitting on top of a sleeping giant. Now, if you're sleeping next to an 800-pound gorilla, you monitor every burp, every snore of this gigantic gorilla, because when it blows, it could destroy the United States as we know it.
This is a pretty scary prospect. I want to just show people what we're talking about here when we talk about this super volcano, and we have a little thing to show you, a map with some of the details. So that's where it is. It's beneath Yellowstone. It's been there, as we know. I guess it's erupted 3 times in 2.1 million years. But what they're worried about is the fact that they say that the ground has started to swell in levels that they have not seen before, 10 inches in some places in the past year. What does that tell us?
It tells us that there is activity in this supervolcano, which erupts roughly every 600 million years. And the last eruption was 640 million years ago.
Oh, 640 million or 1,000?
1,000 years ago, I'm sorry, you're right.
Because then we had some more time.
Then we have some more time, right. But that's what's making us very nervous, because the cycle time corresponds to the present-day era. So every single burp, murmur of this gigantic potential supervolcano, including the rise of the sea level, has to be watched very carefully.
All right, so when we talk about this, and we have pictures pictures of Mount St. Helen erupting back in 1980. Let's just show this right now. You say that an explosion with this supervolcano under Yellowstone, and there we're seeing the Mount St. Helens, would be 1,000 times bigger than this. What type of damage are we talking about here?
We're talking about immediate damage out to 100 miles from the site. That is total devastation, basically wiping out everything in sight. However, the real damage goes out to 500 miles if you include volcanic ash, poisonous gases, death of wildlife and vegetation, and that's a ring about 1,000 miles across. That's the heartline of America.
It would pretty much wipe out Earth as we know it?
It would wipe out the United States as we know it. And again, we don't want to panic anybody. It could happen tomorrow, or it could happen 100,000 years from now. It's black magic trying to predict exactly when it's going to blow, but we do know one thing. One day, it will blow.
And you say that something on this scale is what wiped out the dinosaurs.
65 million years ago, another supervolcano coincided with this meteor that hit Mexico, and we think it was a double whammy that knocked out the dinosaurs. So it's something that we take very seriously, but again, the cycle time is measured on the scale of hundreds of thousands of years.
Would there be anything we could do to prepare or to get people out? I mean, how much of a warning might we get with this eruption?
All you can do is run. You don't get much warning. What happens is the ground starts to rise, more and more earthquakes take place, more ash and volcanic gases start to be unleashed. That's about the only warning we get, because we do not have a good way to predict volcanic eruptions.
Are we getting a better way to do it, or are we just at the mercy of Mother Nature?
We're still clueless. We're still monitoring it very carefully, looking for the warning signs. That's why this sudden rise in the Earth, even though it's not immediately dangerous, is being looked at very carefully, because we have no experience with supervolcanoes. We've seen Mount St. Helens. We've seen Krakatoa. But a supervolcano erupting in our lifetime, we have no understanding of the scope of that thing. We just see the evidence of previous eruptions.
It's amazing. So you say it could be tomorrow, it could be in 100,000 years, but it's under there.
It's there, and it will happen. At one point, it will destroy North America as we know it.
My question is about gravity, particularly about the speed of gravity. We all know that the speed of light is the ultimate in regards to speed, but does this include also the speed of gravity? If the sun disappeared instantaneously, would gravity also disappear instantly or at the speed of light? I'd appreciate your answer. Thank you very much.
Okay, well, your answer actually is not resolvable at the present time, but I'll give you the consensus of almost every physicist who studied the question. If the sun were to disappear right now, we know that it would take 8 minutes for the light from the disappearing sun to reach the Earth. We wouldn't know it for 8 minutes. Now, Einstein says nothing can go faster than light. Even gravity cannot go faster than light, meaning that we wouldn't feel the gravitational shock wave for 8 minutes. The Earth would not be thrown out of its orbit and flung into deep space for 8 minutes. And then the question is, how do I know that? No one has ever done this experiment. Gravity is very weak unless you go to the galactic or the stellar scale. And so for the most part, you never feel the effects of gravity that can be measured easily in the laboratory. So it's quite difficult to do experiments on gravity, and nobody has measured the speed of gravity, because gravity would change so quickly. However, every scientist believes in relativity theory because it works every time, and so we think, but we cannot prove, that it would take 8 minutes for the disturbance of the vanishing sun to reach the planet Earth. Now, one day, we may be able to do this experiment with quasars in outer space, with exploding stars, exploding black holes and things like this. But at the present time, our technology is not sophisticated enough to answer the question, how fast does gravity travel? I'd be willing to put money on the table and say that if there's a disturbance in the universe someplace, we wouldn't know until the gravity wave reaches us at the speed of light.